Well, hello everyone, and welcome back to Adrian's Digital Basement 2, second channel video. Today we have a mail call item. This one comes from James in Lansing, Michigan. And I do know what this is because he clued me in ahead of time. This is something that is gonna need a little bit of repair, so I figured may as well have it on the channel. All right, well, it's a monitor, and there is a letter. Now, the monitor does seem a little worse for wear, but that could well be because he had it open and was checking it out. There's something in here. Let's just see what the letter says. So the letter from James here, it says that he used to use this monitor in the early 2000s and it worked fine. And now what it does is it displays an image only on the middle third of the screen horizontally. So I assume that means the vertical deflection is not working. It says it was given to his brother from an uncle in the mid-90s and he played video games, SNES and PS1. Cosmetically, it's rough, but it worked well the last time he used it. He also includes some extra goodies that he found cleaning up his office, and he looks forward to future videos. So, well, let's just quickly take a look at what's in this purple case here. Wasn't this video games that would normally be in here? Oh, okay. We have, looks like an HDMI to micro HDMI cable, handy. RCA splitter cable, very handy. Another one, that's great. Some Molex splitters, pretty sweet. This looks like 80-pin IDE cable. Oh, Molex splitter with a bird connector, so that's a 3.5-inch floppy on it. This looks like it's, whoops, for a fan. This is a floppy drive cable, a single one. It's pretty long though. Has the twist in it, so this would be for 3.5-inch drives. Oh, we have, okay, an RF adapter here for 75 ohm to 300 ohm. Sony memory stick. Oh no, it's a memory stick duo adapter. This is, God, I used to have a memory stick camera back in the day. Basically, Sony's proprietary memory stick format was like this size, and they made a later one that was half the size, like for a Sony PSP, and this was the adapter you needed to use that. Another splitter. These are always super handy, so I really actually do appreciate these. More splitters. Another 75 ohm to 300 ohm adapters the other direction. A couple more audio type adapters, and then we have some of these, that's funny, PS2 to USB passive adapters. Now these work on devices that were designed to use them, which is stuff in the like 2000s, I think, generally, mice and keyboard. So purple would be keyboard and these would be the mice. And we have some 1/4-inch to 1/8-inch audio adapters. So yeah, cool, little assortment there. This purple insulation is sort of like the stuff that Stuart uses. Nice, there's this packing material on the front here to keep the front of the screen safe. But definitely it looks like there are no screws in this monitor. Let's lift this out of here. So there it is. What this is a Commodore 1802 monitor. It's in pretty rough shape. It's missing the front door entirely. I think that was pretty common. These broke off. Has the little, what do they call it? Pegs, I guess. They're gone and the door is long gone. These are the controls, obviously. It's a 13-inch CRT. This replaced the Commodore 1702 monitor that Commodore sold for years with the Commodore 64. This was supposed to be the beige color of the 64C. And, well, you know, this one's a bit yellow. Let me get this up on the bench. It has a fixed power cord. The monitor pretty much looked like it survived shipping without any issue. I mean, I'm assuming, oh no. Okay, actually, it was screwed together originally, and it looks like the standoffs where the screws go into have snapped. So I guess it didn't quite survive shipping as well as I thought it had. I see the screws are in the holes on both sides here, so yep, that one's there too. So, all right, well anyhow, it's dirty. Yep, pretty dirty. This monitor basically has the same feature set as the original 1702. It's got the separated luma chroma input and it has composite input. And the additional change on this monitor, if I turn this around, you'll see there's extra jacks down here, and that's because the bottom one here is actually a monochrome input. It's just basically a higher resolution composite input. It's the same resolution as the separated YC input, but it's a separate input and it has a green text, or it makes the whole screen green when you use it. It's unfortunately not sharp enough to really use with 80 columns though. There's a switch on the front to select between these three inputs, but because the CRT in this thing is quite, well, how shall we say it? It's low dot pitch, I guess. It means that 80 column text does not show up that clearly. Well, I think at this point I need to take this thing apart and just check for, well, any kind of damage from shipping. It seemed like it was relatively well packed, but the problem is shipping monitors is so difficult. You have to put so much packing material around them because when they're this age, especially with this much yellowing, the plastic is very brittle. And just going through regular UPS, even though the box was not damaged, it just basically can destroy monitors. And obviously, I mean, unless James contacts me and tells me that this was already broken, I have a feeling it probably was not. And that probably happened in shipping. So let me just get these bottom screws out. While I do that, this monitor was made, I'm pretty sure, by Daewoo, so it's Korean, which is fine. Commodore was a big partner with Daewoo for monitors for quite a while. I think quite a number of Commodore 1084 monitors were also made by Daewoo. Their other partner was Philips, of course. Everyone knows that. There's a lot of Philips monitors. And then I think the original 1702s, at least the ones in North America, were made by Toshiba, if I remember correctly. And I think Toshiba also made some of the really early 1084s, or maybe like the 1080 monitor, the original Amiga one of the monitor. So they're very well made. I mean, all of the monitors seem to be pretty well made. Let's see if I can get this back cover off. There we go. All right, well, inside you can kind of get a glimpse of the more original color. It's sort of the same creamy color here as the Commodore 64C, or, you know, the Amiga, stuff like that. And there you can see the plastic that's snapped off. It's probably epoxyable. I mean, this part's still up here, so I just have to unscrew this and get some plastic welder and epoxy that back on. Probably would make that work again. Okay, well, inside the monitor, wow, things are a lot simpler in here than they are on the Commodore 1702 monitor. Those things have a way bigger PCB just jam-packed with electronics. Clearly this is later, the manufacturing. Oh, and let me look at the date on the back cover here. Does it have a date? Yes, it does. November 1986. That's when this thing was made. So compared to the 1983 or whenever the 1084 came out a few years later, allows for some simplification of things. There's some ICs over here. Now there it is, Daewoo sticker. It says who makes this thing right there. It does say, like I said, it says made in Korea on the back. May as well pull this PCB out a little bit just to give it a little inspection. All right, so poking around in here, there's tons of electrolytics, and you know, any of them could be bad, causing an issue. The funny thing is there's this large IC right here. It's a Toshiba TA7670P. I literally watched this video tonight from Jordan Peer about him working on a Toshiba, whatever, black stripe monitor from 1984. And it had vertical deflection issues. And I swear that this monitor on Jordan's video had that exact same IC on it as this monitor, and the issues with deflection were on some small components hanging off that IC. All right, I just brought up Jordan's video again to look at the IC that his set had, and it actually was a different one. But he was really thrown for a loop because he was looking all over for the vertical drive circuit, and he was checking for, you know, various oscillators and things like that, and he didn't realize that this video processing IC, I'm going to point to this one. I don't know if it's the same here, but on his set, this large IC was doing video processing. And I didn't suspect that this IC had anything to do with the vertical, but it did on that set. And on this one, it may, but this here looks like it's horizontal hold control, awfully close to this IC. So these little components here are likely related to that. So I guess what I should do is power this thing on and we'll see what it looks like. I'm assuming it's gonna have a fault, but it could be a bad solder joint, it could be a bad capacitor. Pretty positive that the service manual exists online for this, which is great because that'll make fixing it a lot easier. So yeah, let me flip this thing around and give it a power. Incidentally, just now I found this plastic piece. So this obviously broke off the inside somewhere. Don't know where exactly, but yeah, this was just sort of lying on the bench. So a little bit more damage from shipping. All right, I have the signal generator up on the Sony PVM plugged into the composite input. I set the switch, which is in here now, doesn't come through the front anymore, to composite, and I turned the brightness and the contrast all the way down because I'm expecting this to have a messed up picture, and if you don't have vertical deflection, you shouldn't be running the CRT. It can easily burn it in. I don't know how much James ran it. Let's see if this goes. Maybe it's gonna blow. There we go, it didn't blow. I made sure the power switch was off first, and the power switch is still on the front. Here we go, I'm just gonna step back a little bit. Okay, we have normal high voltage. Let's see what we see. Oh, yep, that's not good. Collapsed deflection indeed. Oh, and it's quite pink as well. That implies that CRT is pretty worn. Pretty worn. Let's see if we're getting anything on here. All right, so no matter how I switch to the pattern generator, it is exactly the same. And oh, it's changed. It was kind of a pink color, and now it's not. I keep blocking the camera, I am sure. It looks the same. Let me just make sure. Maybe I have it in the wrong input. Hold on. Let's try a different one. Okay, there we go. Got something going on. Right, okay, I had it in the wrong input. Let's put it back on composite. And I need to switch this switch over to there. There it is. So we do have some color image there. Keep in mind that the brightness and contrast are all the way at the minimum. And that is not looking so great. We're getting definitely some sync issues there. Definitely some sync issues. Now there are some controls in the front for the horizontal and vertical. So that was the vertical hold there. And this control is the height control. That doesn't seem to be doing anything. Anyhow, enough fiddling around. Clearly it's not working. I'm gonna need to flip this on its side and start taking a look at the bottom of the board, inspecting for broken solder joints. That's the first thing I'm gonna do. Power switch is a little gummed up. All right, so I have my capacitor ESR meter out here, got some probes, I got a marker, and I'm just gonna start probing around on here. I do have the schematics up on the screen, and sure enough, this one IC not only has the vertical oscillator stuff in it, has horizontal as well. So this stuff up here, these components, vertical is going through here. So I wouldn't be surprised if we're gonna find an issue here. Now, there are capacitors marked on here. It does have pluses on the ones that are electrolytic or tantalums that are polarized. And I'm just gonna start kind of going through here and looking for things that seem weird. So, 8.7 microfarad is probably a 10, and I have it 1 kilohertz, and the D value, I'm looking for high D values that look wrong. And it's just, there's no science to this. Well, I mean, maybe there's a science. You just kind of got to get a feel for it. So, okay, 18 microfarad on that one, which seems fine. This one here, C303, it is 800 nanofarads. That seems like it's open. That doesn't seem possible. That's really low. So I'm gonna put a little mark, what was it here, 303. Okay, so here's 303, it's actually 1 microfarad, so that is 1,000 nanofarads is a microfarad, so that's actually okay, close enough. So this capacitor right here is 304, and I'm getting 216 nanofarad, which seems a little weird, but I looked over there and that's actually a tantalum, so that's a typical value for a tantalum. That's definitely too low to be an electrolytic. I'm on 406 and it's reading 460 nanofarads, which I thought might be too low. It's an electrolytic, but I found it on the schematics and it is actually correct because it is 0.47 microfarad. So far so good on all the components here, at least for the capacitors. That's not to say that there's not something shorted here or an open resistor as well. It could be all sorts of problems like that. So just keep looking here. So looking around the board, this section right here is almost certainly just video processing, and that has nothing to do with the sync. So I'm not really going to spend a lot of time over here. Now, unfortunately, the schematics are like really low quality scans, so it's not great. Let's see, I'm just trying to trace what's happening here. That loops around, goes to this side, really? Invert amp, bias. All right, yeah, vertical height. Okay, that's what that was going to. Vertical height control. Okay, so for these pots here, horizontal position, according to the schematics, it's the little red multimeter there. 20K, that's correct. Vertical hold, where is that? Again, super frustrating that this schematic here is so haphazard. H position, well, there's the height, vertical height. So vertical height's this one. Should be 10K. Okay, yeah, if I turn it all the way up, we get 10K. So that is fine. No problems with that pot there. There's also a linearity potentiometer on here. That is labeled R309, and it is V linearity 100K. There it is right there. Let's see what this one measures. So we're getting 8K, 8.6. Let me just fiddle with it, twiddle it on the other side here. So yeah, we're getting 95K. Okay, so that's that one's fine as well. I mean, it kind of was adjusted to that 8.6. Actually, the fact that I had the reading there, I can just set it back to exactly where it was. Let me get these probes on here. I really need to get my clip probes out. Yeah, this is not good holding it. Okay, no good. I got to get the clips out. Fortunately, these clip probes are falling apart. They're cheap, like AliExpress. Oh, they just fall off. So crappy. Yeah, they're from AliExpress and they're just junk. Really, really not good quality. So that they do not hold on properly. Let's try this again. All right, at least it's holding on enough so I can adjust it back to where it was. Get it back to the 8.6. So the linearity is connected here to the vertical oscillator. I'm looking at the schematics. That goes through a resistor, which is 39K. Let me switch back to my other probes. All right, so this goes to this one, 308, which is 39K, which is exactly what we're getting. That goes to the IC right here, and then there's a tantalum. It says it is 35 volts, 0.22 microfarad, capacitor 304. There it is. I'm just going to check that it's not shorted. So 10 kilo ohms definitely is not shorted. That goes through. There is resistor 304 right here. That should be 10K. That's 10K. Then it goes down to R307. That's right here. R307. That one is, what is that? 8.2K, which that's what it is. That looks good. Then off this pin here, there's another capacitor. And that one is 2.2. 2.2, that looks good. That's part of the oscillator, so definitely needed to check that. Sync gate, then pin 30 here, which is on this side, has this capacitor here, which is the one I marked with red that looked weird. That one is supposed to be 2.2, no wait. That should be, yeah, 0.22 microfarad. No, wait. Okay, here's capacitor 304, which on the schematics is 0.22, which is exactly what we're getting here. Yeah, I'm not really seeing a problem in the vertical sink area of this IC here. There's like horizontal output here, sink gate. We have the sink separator here. It definitely was sinking though, because when I adjusted the horizontal hold, it was rolling, and then I adjusted it and it kind of locked in. It still looks screwy. So I'm assuming the problem might be in the drive circuit itself. This circuit on this IC here is the gate circuit. So this is like what's generating the actual signal that drives the transistor that then drives the vertical. I bet you this problem is beyond here, somewhere else. Okay, so I'm looking and it looks like the vertical drive makes its way, kind of like snakes through this, and it goes over here. There's a jumper link there. It goes down, here's 306. 306, according to the schematics, it's a tantalum 0.22, so let's check to see if it's not shorted. Nope, we're getting 71K. And we're getting 0.22 on the capacitance, so that is definitely okay. I mean, tantalums fail short typically. All right, turns out up here there's another IC, I guess. It's called IC 301, and it's got vertical deflection stuff going on in it. Pulse width adjuster and voltage booster. So I need to check around there as well. Oh, shush, who's beeping? I don't know, maybe it's you. No, it's this one. IC 301 is right down here. It's sort of like an upright package because it's just a single line of pins here. So we got C308 is an electrolytic that hangs off of this here. Here it is right here. 92 microfarad is what I'm measuring, and it's 100. Yeah, and the D value is 0.3. Okay, that cap is okay. And then we have 318. Here's a cap, 318. This looks like it has something to do, it's a very big cap, 35 volts, 470. It's like it's something to do with the deflection. If this one's dead, then it probably won't have enough stored voltage, or no, that one's okay. That one is okay. It's reading 390 microfarad and the D is 0.6, and it's supposed to be 470, but I have it at 1 kilohertz here. So yeah, the vertical runs at 60 hertz. So if I switch this frequency down to 100 and we measure that again, then we're getting 407. I mean, it's still kind of low-ish, but I don't think that's low enough that it's not going to work at all. Unfortunately, one thing that really kind of blows about the schematics too is like a lot of the lines are just, it's like 500 generation copies later. So the lines just sort of disappear. You have to kind of guess at where they're going. In some of these instances, it just sort of turns to nothing. All right, down here, this is the connector that goes to the yoke. I'm gonna check, and yeah, I didn't resolder or anything because everything actually looks okay on this board. There's a pretty large cap here, 220 microfarad at 25 volts electrolytic, and that one we are getting, let's keep falling off the leads, 202 with a relatively low D, so I'm going to say that's fine. We have cap 309, which has got to be around here somewhere. There's 310. Let me just measure that while I see it. 100, it's fine. Here's 309. It's funny, it's got minus marked on the board. Okay, so we're getting 1000 nanofarad. That cap, yep, 1 microfarad, 35 volts. Okay, that one's good. Okay, 310. Did I just measure that one? Or is it 310? Yeah, I think I did. That one is supposed to be 470. 310. Let's make sure I have a good connection on here. Okay, I think this is bad. We're only getting 100 microfarad, and the D is 4.5, and cap 310, which is definitely what I'm on right now. This cap should be 470 microfarad at 35 volts. So let me mark that, 310. Let's just flip the board, and I need to see what this actually is, because maybe the schematic is not correct. Nope, that is 470. And that is definitely not good. Okay, so I'm going to pull that out. 470 at 35 volts, and that is definitely right on the vertical deflection circuit. So if that's bad, there may not be enough to, you know, get full deflection, and that's sort of what we're seeing, right? We're seeing kind of a half deflection there. So let's get that out of this board. It's got some glue holding it down. Okay, just popped right out. Pretty easy, actually. Oh, that I don't think was glue. I think that was leakage. Let me see if I can get a better shot of that. There it is. That would be gunky leakage. And all right, so let's see. Let's measure this directly on the ESR meter here. This thing has got some little slots here. You can just slot the cap in. I don't want to get gunk on the contacts. Okay, here we go. Because, you know, sometimes in circuit it doesn't really test, you know, perfectly well. Yeah, I'm getting nothing on it. So it appears to be completely dead. Let's find a replacement. Okay, so I have 470 at 25 volts. That's not good enough. 270 at 25 volts. I should look at my stock. I have a stock sheet where I kind of keep track of what I have in stock. 560 at 10. Clearly that's no good. 1000, that's no good. I know you can't read it, but I am checking my spreadsheet. Unfortunately, all I have in stock is a 470 at 25 volts. Now, if the value is not quite right, like say it was a little bit higher, that would be okay, capacitance, but the voltage, you gotta at least match what was on here. And this was 35 volts. So what else do I have in 35 volts? Gosh, I don't really have, I mean, I have 1000, but that's quite a bit more. So I think I'm gonna have to go to my spare parts boards and pull one off an old CRT or something. I have a bunch of junk CRTs. Let me go do that. Here's a spare parts board. I think this was like a, I don't know, some kind of a VGA monitor that was well used, but it does have the exact cap I need. It's right here, 35 volts, 470. So I'll pop this out. We'll hope it's good, because this, if I recall, this monitor was very used. So it's probably baked to some extent as well, but I don't have anything else. And of course, the whole monitor is kind of baked. So let me pop this out and we'll test it first before I pop it in, but hopefully it's good. Beeping, everything's beeping. Okay, so this is the one I took out on the left. Hopefully that focuses. It's 35 volts, 470 microfarad. It's quite a bit bigger than the original 470, 35 volts. 105 rated on this one, and this one, 85C, of course. Let's just pop this in here to this. Let's see if we get a good reading on it. Let's see what we get. Yeah, give me a good reading. Come on. There we go. 1 kilohertz, we're getting 422 with a nice low D value. So that's a good cap. Let me just clean up the solder on here, and then we'll pop that in there, and we'll see if this monitor is fixed. I have a feeling that's gonna do the trick, because this is critical component for the vertical deflection, and it was dead as a doornail. Clean up these leads a little bit. They're a little bent. So before I put this in, I was gonna clean the board. Can you spot where the issue is with the bad cap? Yeah, right there. Notice what's near it? These power resistors, which probably get super hot, and it baked the heck out of that. Now, if I were smart, I would have just taken a very close look at this board first and noticed all this brown gunk right there, which probably could have clued me in that there was an issue. So I think a good lesson to learn here is just, you know, take a look with your eyes first. You don't even necessarily need to, you don't need to use test equipment. Oh, this board is baked. Ugh. Yeah, it's real crusty in here. Just use your eyes. And I remember that Sony TV I had that didn't turn on all the time. Well, I just used my eyes and I found, you know, where it was really, really baked looking. And then I looked at the capacitors near it and I did use my tester there. This is coming off little by little here. And with the tester, I was able to identify, where's my, the alcohol kind of went over here. Let's keep going here. Oh, it's so gross. It actually damaged the PCB there. You see that? It's actually damaged. That corrosion really did a number on this board. In fact, this power resistor here is effed up as well. Gonna get something here to kind of scratch away at it a little bit. Just try to get some of this gunk off of here. Ugh, gross. Capacitor grossness. Yeah, it did corrode the lead of this resistor as well. Look at that, look at that. Nasty. Now you could be fooled. I don't know if the focus is gonna work that well because of these wires, but this cap has a bunch of white stuff there. That's glue. That's not leakage. So you have to kind of tell the difference. And there's some glue down here. See that? That's glue. So you gotta know what you're looking for and realize that, oh, I think there's like a hole in the PCB. Oh no, this comes off, okay. With enough scraping here. Anyhow, yeah, so use your eyes. Look for things close to hot things. Like I should check these capacitors here and here, this little one there, because those might be bad as well. But this one was definitely baked. Look, power resistor, there's 4 resistors and it was right in between all of those. If I had longer leads on the one I'm gonna stick in here, I'd actually like raise it off the board so it wouldn't be so close to those. But this monitor is pretty rough shape anyway, so I don't think it's gonna get used, you know, hundreds of hours or thousands of hours. Look at this. Look at the color of that Q-tip. Yuck. Nasty. All right, well, it's definitely cleaner than it was. The PCB itself is pretty baked, but that's where the cap goes. At least I can see the silkscreen markings on there. So I'm gonna put this better, bigger cap on here. Of course, it's still gonna be kind of close to these resistors, so maybe I'll bend them away a little bit. I don't know, it's not really much I can do. So it is marked on the other side which way is plus, but there's also a little notch or white thing there. That goes towards the negative on the capacitor. So I just pop that in there like so. And now I just need to reconnect it with some solder. Just want to make sure it doesn't fall out as I tilt up the board. So I'm going to kind of hold onto it with my finger. And as I said, there's a plus right here on the bottom, and it is towards the bottom, and the stripe on the cap is towards the top, towards this top edge. So the polarity is correct. Just make sure you get that right when you put a cap in there. So we're just gonna pop this in here. Oh, and it fell out. Sheesh. So I'm just gonna hold it with my hand while I apply some solder to it. There we go. And the same thing right here on the other lead. Oh, the board is moving. Stop moving. Let me get you fixed. Let me get you in the board. Stop complaining. There you go. Look at all this brown gunk. This is actually the juice, and it's really sticky. Ugh. So I think I will get the alcohol on here, and I'm gonna get a paper towel because it left a big brown spot on the anti-static mat here. So we'll just put this like this, and where's the alcohol? Spray it on there. It's gonna drain down onto there. I'm gonna get a toothbrush, scrub that a little bit. Hello, toothbrush, you're not for cleaning teeth anymore. You're for cleaning capacitor juice off circuit boards. Oh, this is disastrously messy. Yuck. Now there's a lot of flux on here, that's what this is, and there's leftover flux. That is from when this board was manufactured. Oops. So I'm not gonna get all that off. I wanna get the majority of the sticky juice off. Oh, Yeah, you don't want to wipe your face with that. No siree. Ooh. Oh, it's so horrible. Wow, this is so gross. Amazing what one bad cap. You're so bad. Look at all this mess. Okay, I'm just gonna blow this off, dry off the alcohol a little bit. I use this awesome air duster that was sent in by a viewer. It's ESD safe and everything. It's just like a vacuum cleaner motor with a nozzle on it. It's great instead of using up this kind of stuff. I use this sometimes because it's quick, but that can's almost empty. This thing blows like crazy, crazy amount of air. So I'm just gonna dry this board off here. It's gonna blow things everywhere. Here we go. And that is all she wrote. There we go, not sticky anymore. Love it. Still a bit sticky, so there's obviously some gunk left behind on here. Oh, let me just blow this, blow the air on there as well because I see alcohol residue. Just gonna dry it off. Okie dokie. Let's plug this deflection yoke back in. I had to unplug it to kind of position the board like that way it is. Someone tied a knot at the factory. So this goes back on like so. Bada bing, bada boom. What else did I unplug here? I know I unplugged a speaker. That doesn't matter. Where is the speaker? Oh no, it wasn't the speaker. Oh yes, it was the speaker. Here it is. That doesn't need to be connected. So the yoke is on, high voltage is on. Let's move the soldering iron wire up here. Let us grab the composite signal, plug this in. Okay. Alrighty, look at this mess. Look at this mess I made. All these caps everywhere. I didn't even use them anyways. Okay, well, I'm gonna plug this in. I'm gonna have it on its side like this, but that's totally fine. Okay, mains power is connected, so no touchy. Here we go. I hear the deflection. What are we gonna see? Oh, yes, there it is. Let's see if I can turn this. Okay, look at this. We have full deflection, so I can turn the brightness and the contrast back up again. There we go. Nice. Very nice. The tint is way off, but that's fine. And look at that. It looks good. I mean, I measured those other caps and they actually seem fine. They were Daewoo branded. Everything in here is Daewoo branded, including those caps, including the bad one. All the other ones I measured, they all seem pretty good actually. And the fact is, at least I'm looking at a very extreme angle because the camera is in the way, but it looks generally fine. So I think what I need to do is power this off and remount the board in here. And yeah, let's give it a little tune-up once it's back together again. All right, I'm getting this thing ready for a tune-up. Before I do that, I need to deoxit those pots. Whoa, yeah, this thing is such crap. Look at this. It's gonna leak all over the desk, and this can is nearly full. It's so frustrating. Do not buy the Deoxit D5 with this particular lid. There's another one that has like a normal, looks like a spray paint can. Get that one, because this one is garbage. It's just garbage. Anyhow, I'm gonna spray these pots down. Okay, there we go, that should do it. And I'm gonna slide this back in to the monitor. Okay, just make sure everything comes through the front, and it did. And I'm just gonna give it a reach around, and I'm gonna turn those pots back and forth. And you can tell the deoxit's in there because it becomes very easy to turn. The Deoxit D5 has like a lubricant in it. So you just sort of go back and forth, which is what I'm doing on all these pots. These have a detent in the middle. So you just do that back and forth, back and forth, back and forth, till you feel it turning smoothly. I think I forgot to hit the volume. Yep, the volume one is over on the side. Slide this back out again. Way over there. The power is not applied to the monitor, by the way, while I'm doing this, just by the way. So yeah, in case you worry that I have my hands near here, the power cord is unplugged for my safety. And the front switch, there's 3 positions. So move that back and forth. Okay, I think we are good. There are 3 other, the adjustments for like the vertical hold and stuff, they are recessed, so I have to use a screwdriver to turn those, but I did hit them with Deoxit, so those turn a lot easier now. I think what I'm gonna do to make this easier, I'm gonna turn this around so the camera can see the screen. All right, I'm ready for powering this up. The power switch is on, so here we go, into the wall. All right, do not worry about this. This is because I was fiddling with all the controls, and this rightmost one was the vertical hold. So that got that back on track. And then we have vertical height, so there it is. This is the control I was trying to manipulate before. And there it is, looking good. Now, one thing that's funny about this monitor is the entire picture is sort of shifted down. And that's because I think it was really designed to be used with the Commodore 64, which, if you know that machine, its picture is kind of closer to the top of the screen. So with a monitor that allows you to move it up and down, you definitely have to put it down, and the border on the top is a lot thinner than the border on the bottom. So this monitor does not have a control for that, not that I've seen at least on the inside. Definitely nothing on the outside here for the position vertically of the picture. So yeah, as you noticed when I had the height adjusted like this, notice we're already seeing a black border there, but we're not seeing one on the bottom. And that's pretty much the way this monitor is designed to work. And I know this because I actually have another one of these monitors that I just recently got. It didn't have any faults, and it's exactly the same as this one. All right, so on the front, controls are pretty standard affair. We have volume, then we have the switch between composite. This is the separated, luma, chroma, and then there's the monochrome one. So there's those 3 positions. We have the tint, the color, the contrast, and the brightness. So the brightness is set to the middle right now, and the contrast was also in the middle. Let me turn off the overhead lights. So I've done a bunch of videos about adjusting the settings on monitors, and there's better videos than mine, that's for sure. But to get the brightness right, you want to make sure that you can just see these bars down here. They're in the black area, and I can see them, but they're a little bright, so I'd almost turn this down a little bit. Now there's a sub brightness control on the inside, but you know what? I don't feel like finding that, so I'm just going to turn that down. So there we go. I turned down the brightness a bit, so this is a bit better. I turned up the contrast. It's a well-used monitor. It's not super bright. This is the color control, so this is the center detent. Seems okay. And the tint control, that seems fine too. Probably could use a little bit of an adjustment. Volume control is over on the side, and then yeah, these other ones. So let's switch to some other patterns. Let's see how the convergence looks. It's not too shabby, the convergence here. I mean, it's got a little, well, I don't even know if it's got rotation on it. Probably not, actually. It's a little soft in the corner, but par for the course. This is a 40-column monitor designed for use with like the Commodore 64 or things that run at 320 resolution, and yeah, I mean, there you go. It is pretty dirty. Let's put a little Windex here on this cloth. See what comes off the CRT here. I think it's gonna be pretty dirty. Yep, that's a relatively dirty cloth. I mean, I've certainly had worse when it comes to monitors that were in far worse shape when it came to the filth factor. Well, on composite, this appears to be working perfectly, so let me go grab Commodore 64, and we'll hook up the separate signal, the Luma Chroma, and we'll see if we're getting that nice, sharp S-video type signal on this monitor. Got the ZIF 64 hooked up. It's hooked up to the separate inputs, not the composite, so let's swap the switch over to the middle position and power this up. Oh yeah, there we go. Hey, okay, so let's see, I can adjust things a little bit. The position, we're gonna move this over. And let's shrink down the height. There we go. Look at that. Yeah, see, that's what I was talking about. It's pretty centered on there with the 64, even though the whole picture is shifted down when you actually look at the regular NTSC color bars. It's looking pretty good with this. I got the easy flash here. Let's hear if the sound works. Let's see if the 8-bit dance party is possible. This thing. Let's see, look at that. Look at that. It's looking really good, nice and sharp. No issues whatsoever. In fact, I think even the grayscale adjustment, which is like the drive controls for the CRT, they look good. So this CRT in here is in decent shape. Not bad at all. So we're gonna go to Adrian's tools and we're gonna do 8-bit dance party. All right. Pretty crappy sounding speaker. I mean, it works, but it's probably a little tiny thing. The original 1702 had a nice big speaker on the top, had much better sound than this monitor does. But it works. Nope. Yeah, no issues with the sound. I'm sorry I didn't dance to that. So this monitor is fixed, at least from a deflection standpoint. I mean, there's still physical problems with it, but at least it's working now. It was this one capacitor that had leaked all over the board, and if I had just used my eyes, I could have avoided all of that troubleshooting and just swapped this out or measured it and found that it was bad, popped the new one in, and then the monitor would be working. So some people would have said a recap of the monitor would have fixed it. And yes, in this case, that is true. But it's much better to try to figure out and understand what the problem is so that you can actually find the faulty component that was bad, not just shotgun the entire monitor like hope a capacitor change is gonna fix it. But understanding what the fault is meant that if it wasn't a capacitor problem and say it was an open resistor or some other problem like a transistor that had gone short or a diode that had gone short, figuring out the circuit and probing around with your multimeter, and also like I use the ESR meter, which incidentally I think was not that expensive. I got it from Amazon. You can figure out the problem and fix the actual fault, not just shotgun it. And you know, to be honest, I'm not going to change out the rest of the caps on this monitor. They tested fine in circuit. And I guess Daewoo made good quality caps in 1985 or whatever, 86 when this monitor was made. And this poor thing was just baked because of those nearby resistors. So if you have an 1802 monitor and it doesn't give you full deflection and it does something similar to this, or you know, say it's rolling over or it's maybe not as small in the middle, but it's still not full, suspect that this cap, which is baked by those resistors, is the problem, and just swap this one out. And feel free to take it off an old dead board like this. Like this was an old VJ monitor that I sent to e-waste. The whole monitor went bye-bye, except I kept this in my parts bin. And you know what? I've actually probably pulled other parts off here. I don't really remember. I mean, the PCB is cracked at this point, but that doesn't matter. The components on here are still good. And sure enough, fixed this monitor right up. So if you enjoyed this monitor, I mean, if you enjoyed this video, I'd appreciate a thumbs up on this video. Definitely, I wouldn't mind a sub on this second channel. It really helps me out. YouTube just doesn't direct as much traffic to your videos if you don't have as many subscribers. It's kind of like a feedback loop of sorts. So I'd appreciate a sub on this channel. You know, check out my main channel if you haven't already, Adrian's Digital Basement. Big thanks to my Patreon subscribers, or my patrons, that is, my supporters on Patreon. Look at this, I'm totally messing up the outro. Thanks to my supporters on Patreon, that's what I'm trying to say. Really makes a huge difference for me. YouTube revenue is way down over the summer. I don't know what's going on. I think and now that weather is nice in the Northern Hemisphere, everyone's out and about doing stuff and they're not watching videos. Anyhow, if you enjoyed this repair, yes, a thumbs up and put your comments down below if you haven't already. And yeah, that's gonna be it. I'm gonna stop babbling now. Stay healthy, stay safe, and I'll see you next time. Bye-bye.